Hello YouTube viewers, welcome to my show Future Friday. In today's episode we're gonna take a look at how do we actually terraform Venus. So before we understand about terraforming Venus, first we have to understand why the heck I'm not talking about Mars but I'm talking about Venus. Now to give you a very simple idea, like very simple, it's a long-term solution. What does that mean? Think of it this way: if you take entire humanity's energy, the gross domestic product, basically you took entire humanity as like, okay, I'm gonna give you 500 years, do what you will. If you put that 500 years into Mars, you will still have Mars. But if you put that 500 years of time on Venus, you will have Earth 2.0 with almost identical situation. And it is a very long-term solution. Even when scientists are like trying to optimistically predict what will happen if we terraformed Mars, the answer always comes down to the same fact: it will not hold the atmosphere. It's, as you can see in this picture, you should get a clear idea how small Mars really is. Venus is almost like Earth, and it is also inside Goldilocks zone. The reason why it's hot is because of greenhouse effect. Now this is the reason why humanity even knows about greenhouse effect, because it did not mathematically make sense how the heck this can be hotter than Mercury, which is the first planet in our solar system. First as in from then it is the closest to the sun. How the heck that can be colder than this? So this taught us very important thing, and it is a very realistic glimpse of what could happen to Earth if a runaway greenhouse effect happened. Now, what about terraforming Venus is very simple. It's classical terraforming. When I'm talking about classical things, as in nature already does that. This Venus format that we have, it used to be earlier Earth. Basically, old Earth would look more or less like Venus. So there is a natural tendency of things to help out, like CO2 atmosphere, for instance. Earth had very substantial atmosphere that was mostly CO2. However, over time, life bacteria actually started digesting CO2 and emitting out O2. And hilariously enough, they ended up dying because of oxygen. The atmosphere was polluted by oxygen. From the bacterial points of view, oxygen was deadly. So, things happen, and not to mention it did took millions of years, but from a planetary point of view, it's nothing. Be mindful, oxygen is not stable. So if you ever find oxygen rich atmosphere in any body, like any celestial body, there is a very good chance it's actively being generated or there is life on it. So this is a very interesting part, that it can be classically terraformed and it's closer to Earth. That means travel and trade between these two puppies are much more common, easier, and communication lag, as in light lag, is also less. And one thing you can't give Mars, no matter what you do, no matter what kind of fancy magical technology we are talking about, it's gravity. So to understand gravity in itself is that this is 0.4, this is 0.9, this is 1. So here, if you walk here, you will feel a bit light. If you walk here, you will feel like a Superman. Here's the problem with that: if you stay on Mars, as in long term, or as in you were born on Mars and things of that nature, you come back to Earth, you will die because your own body weight will be so high that your bones will not be able to handle it. This sort of effect has been observed and properly catalogued when astronauts come back from 0G from ISS. So we know for a fact that zero gravity is gonna kill you. We now even know a time frame, and we know for a fact there is a correlation like 1G to 0G. So best estimate is like we can only live there for 4 to 5 years. Like, of course you can live there indefinitely, it's just that you can't come back to Earth. Now, how do we actually do it? It sounds all fun and games, like you ask Elon Musk, he's like, yeah, we can terraform Mars. How? So how in Venus terms, it's super easy. All we need is sunshade. Now sunshade and solar sails or light sail is more or less the same thing, something that reflects light, not absorbs it. Be mindful, you don't want something black that is absorbing it. You want something that reflects it, like this. This is Mylar based, and to give you an idea how good we are with this sort of technologies, like if you want to make 1 kilometer square kind of sail or sun blockade, it can be made from 100 kgs of aluminum. That's it. And So we can make the shade, and shade has to be made on moon. We cannot do it on earth simply because unless we have orbital ring around the earth, we cannot transport that kind of mass away from earth without roasting earth. So for that point of view, moon mining has to be done. Like, how do we do it? We put solar shade. Where do we make that kind of solar shade, like millions of kilometers large? And I'm not talking one large piece, that's simply not feasible. Multiple small ones. So we have to figure out moon mining. Now you can check my detailed video here. So now we have moon mining. Before moon mining, don't even talk about it, don't even think about it. It's like it has to have moon mining. So we have small mirrors there, and moon has boatload of aluminum, so that's also good. Now it's gonna take a long while, and under no circumstance think of it this way: okay, I place the solar shade and it's gonna cool the Venus instantaneously. It will take time, upwards of 200 to 300 years. Now then the question becomes, okay, where are we gonna place the sun shade? We're gonna place it at L1 point. Now be mindful, if you place something on L1 is not stable in orbital direction, as in if L1 from L, it will move towards L4, it will not come back. If it moves to L5, it will not come back. But if it moves towards, let's say, L3, it will fall back. If it moves towards the planet, it will fall back. Like it's gravitationally stable in two directions, but not in every direction. Like L5 and L4 are very stable. Now if you place something on L1, the shadow it will cast. Now of course there will be a lag at first, when it's coming into when eclipse is starting to happen, it will take time. Now once that shadow is there, it will move in sync, there won't be any lag. So it's basically you are creating an eclipse scenario to cool down the planet. So, and thankfully we humans are lucky that our star is very bright in infrared, which is very easy to block and reflect from aluminum. If it was bright in, let's say, gamma ray or X-ray, yeah, we don't know anything that can stop it or reflect it easily enough. So that's how we do it. That's the inherent principle of it. Okay, let's say we did that solar cell, so a giant solar shade. What's gonna happen after that? Now in 200 times, like, do not under any circumstance misunderstand that. That's the optimistic one. Now of course the worst case scenario is still 300 years. It's basically from that time zone. So the reason is why it's that long is simply because a planetary body is basically in a vacuum. A planet is in a vacuum, like it's surrounded by vacuum. So how the heck it's gonna dump the heat away? So it can only dump the heat away in using infrared, basically radiation. Now you might be like, okay, doesn't CO2 absorbs it, which is the problem with Venus? Yes, but no amount of insulation is 100% perfect. Even CO2 lets some infrared out. However, the sun is inputting so much and output is not balanced. That's why it's so roasted. So if you remove the sun's input, the output is still there, but over time enough output has happened that it would have drained the system, as in the CO2 will become ocean. Now like, okay, I remember from school that CO2 only goes from gas to solid. True and false. True, it happens on Earth. False, because it's directly dependent on the pressure, basically. So as the Venus atmosphere starts to cool down, because Venus atmosphere has so much pressure, it will compress the CO2 in such a way that it will become liquid. Now once the pressure starts to drop, then it will end up creating what we call dry ice. So you will have a scenario where you will have a liquid ocean of CO2 and you will have dry ice covering it on top. Now you might be like, okay, let's say we removed solar shade, wouldn't that come back to surface? Yes and no. It will come back over time, and I'm talking millions of years, and that is like without any human intervention. But the problem is that once you removed enough CO2, it's not Venus is not like Mercury. It's not very close to sun, so it will take very long time. And this time there is no CO2 in the atmosphere. Like, of course there will be a little bit, undeniably so, but there is not enough. And CO2 ice is very reflective, so it will remain cold. And be mindful, the amount of energy you removed, that's a very big amount of energy that you removed from Venus, like passively, undeniably so. Heating it up will take again that amount of time. So we'll have oceans of CO2, and it already has oxygen and nitrogen rich environment. Now I'm going to be like, okay, where the heck it has nitrogen? It only has 3% nitrogen in its atmosphere. That is true, but because of the Venus atmosphere's size, 3% of Venusian nitrogen is much more than what we have on Earth. So be mindful, like it already has nitrogen. We don't have to transmit or transport insane amount of nitrogen. It already got it. Heck, it might end up too much. So we already have nitrogen there. It's just that we have to figure out what to do with CO2 for long term, and I'm talking longer than few million years. and it will be more or less like Earth at that point once it has cooled down. Now of course you can let's say if it started to cool down, let's say you did not remove the sunblock or completely made it opaque. Over time Venus temperature will keep going down and down and down and down, and sooner or later it will reach cryogenic temperature. But if you don't want that, it's like, of course that will not happen. It's not like our sun is not giving out any X-ray or gamma rays that will go through our shade, but we can still open it up a little bit to make sure the light is coming and warming it up, so we can control the temperature. So it's 200 years now. What we can do in that time, like it's unfeasible to tell someone like, okay, we're gonna start this project, and they're like, okay, what we're gonna do? We're gonna do moon mining. They're like, okay, I have the mines in the moon, and here's you do with what you have to do. After that, it's like, yeah, we have to wait for 200 years. That's really wasteful. What we can do in that time is figure out power and transmission. Basically, power wise, biggest problem with our current situation is on Earth is that we don't know or have any proper source of power. Here we already have the luxury of solar power. Now I'm like, how the heck we have solar power? We already put giant solar shade, and I specified that it cannot absorb light, it has to reflect it. All we have to do is create it in a convex shape, basically why I'm saying convex, concave shape, and make it into a basically solar dish. And using that we can extract power. How much power we are talking about? Well, you shaded the entire planet, so we are talking about upwards of 100 to 300 terawatts per hour. You can check my more episode about solar thermal power here. So it is a lot of power. To give you a context, that kind of power, what kind of power we are talking about here, it's more or less Earth's current power consumption with everything combined, it's barely 20 terawatt. So you're gonna be fine for a very long time, all things considered, because that shade is that huge. And you don't have to make, again, you don't have to make one giant solar cell. I'm saying one solar power collector. You can have multiple small ones. You may not even need the whole cell. You just on the periphery you can make enough of them, and that will provide enough power, because I told you, like hundreds and hundreds of terawatt of power. At this point, if humanity ended up with a reactor that gives us 100 terawatt of power, we don't know what to do with it. Although we will start removing carbon dioxide from our atmosphere, so we can solve the power issue. That will be the, like, once the shade is there, then we'll start converting that shade into power collector. Then on top of that, the biggest problem if you want to create a space-faring civilization is that rockets are not efficient. Flat out, rockets are not efficient. Now like, what about space elevator? We cannot make space elevator on a planetoid simply because gravity is too strong. You need magical material like carbon nanotube, and not to mention even carbon nanotube is stretched to its maximum limit, so it has no safety margin. You like even a minor dent or damage, it will tear apart. However, we can create something that gives more throughput than space elevator. It's orbital ring. Now Isaac Arthur created a very amazing video on this topic, and either I will link it here or down in the description below. You can check it out for further detail. But this can be built with today's technology. It's just very expensive. So, but if you have moon mining and if you want to create a planet, doing this right now, it's very easy. Now you're like, if it is doable, why the heck we should not do it on Earth? Simply because politics. On Earth we have the easiest place to build this would be around equator. Now problem in Earth scenario is like, if you did it around equator, the tethers, as in like the cable that is going down, that is your basically cable on which you are going to go up and down. That is barely 200 kilometers. If it is 100 kilometer up, you will of course not have a direct line, you will have a diagonal line to act as a brace in both directions. So USA is there. USA is not close to equator, so you might be like, okay, let's tilt the ring. Now problem is the ring covers the USA but does not cover other things. So our politics will not allow this sort of mega structure to be built on Earth. However, on Venus, because we are starting out, we can start the whole colony system around this ring, basically wherever the tether is landing. So we can start colonizing from the equator. This way we solve two problems. First, power issue is solved, then space transport. So these two things are solved in the time while it's cooling. Like this is not something that you will do after Venus has been cooled. You will do something before it's cooled, because once that cooling process is done, people would want to go there right now. So you want to build this before that happens, so they don't have to waste time using rockets. Then to give water, Venus lacks basically water. How do you give Venus water? First simple thing we have to do is do hydrogen mining. Now hydrogen mining is very easy in the outer reaches. Now my personal favorite for hydrogen mining is basically Titan, Saturn's moon. Why? Well, it has hydrocarbon plus water. Now, many of you know who are familiar with industrial hydrogen production is that we simply make it out of petrol. Yes, hydrogen is produced out of petrol. It's called steam reforming. You can look it up how that works. And the reason for that is like it's very simple. From if you want to talk to about electrolysis takes a lot of energy, as in joules, compared to the steam reforming. Steam reforming takes much less. That's why we use steam reforming. Now, steam reforming requires two components. Component number one, hydrocarbon. Component number two, water. Both are present here, and benefit of this is that both are present in very easy form. Like water is in ice, we can handle ice, we know how to handle ice, and we just need a hose and just dump it in the lake. So very easy. Now what do we do with hydrogen that we got? Of course we have to liquefy it. Liquefying it requires a cold temperature. This place is very cold. It's as close to cryogenic as you're gonna get, so we already have that cold temperature. Now be mindful, solar energy is not gonna work. Any other thing other than nuclear technology, nothing will work. RTGs does not have enough power to create enough of it, so we need nuclear fusion to get things working. If we figure out fusion, that's awesome. If we don't, we have to go back to fission, but it is doable. We know how to do what we call steam reforming, and it's nothing fancy. And if you have liquid methane, if you have boatload of ice, and if you have a cold environment, you can do this process very efficiently. I'm talking like liters of liquid hydrogen for few kilowatts of power. That's very, very optimum. Now we have to build space elevator here. Now since thankfully it's very small, it has very low surface gravity, so elevator has to be made of normal things like Kevlar. Why elevator? Why not use maglev that you can use from moon? Simply because it has an atmosphere, so it is very good for landing there. Atmosphere will help you land, but to get off it you can't rely on maglev because the friction will be too high, but space elevator will work. So this is way you will do hydrogen mining. Now why hydrogen? Simply because 1 ton of hydrogen equals 18 tons of water. So what could this sort of thing require? Like I'm talking about future Friday, and I'm talking about a very far out concept. So what would it actually take for humanity to do something like this? Physics says okay, this can be done, but physics has said hundreds of things. So many things are possible in physics, but it's about money, it's about time, it's about patience. So what will it actually take? Like I removed one thing from my presentation, is like how do we gonna fix the day-night cycle? It is doable with mirrors only. You don't need magical thing. And because I have not settled on yet how do we actually fix it, like actually as in like my preferred way, so that's why I haven't made it. There are hundreds of options, each one to each is their own. That's why look it up how we can fix it. So first thing we need is the time frame is too high, but it's not too far apart. Like think of it this way, Great Wall of China took longer than that. USA's history so far, let's say tomorrow USA dies, still would have lived longer than the time period we are talking about. It still have lived around 260 years or something like that. So that time frame is long to us, but it's not truly long. Like Roman Empire was classified as 900-year-old empire. That's a very long amount of time. That means if they had started this Venus terraforming, their citizen would have lived long enough to see the flourishment of that system. So first thing and foremost, for this sort of projects to happen, we need longer lifespan. Now I'm like, okay, that's a pipe dream, humans living longer. We already live 3 times longer than our pre-industrial counterpart. We have already achieved it, and in recent time doctors have finally starting parsing what we call aging. Now aging is no longer like aging, it's a disease. It's like, okay, this is breaking down, this is breaking down, this is breaking down, and we are trying to fix that. Now of course it's not like a magic cure is right there, right around the corner, you're gonna get an injection and voila, you're gonna live to 300 years. There is a lot of process needs to be done, but we can easily expect to extend average life to 100 years in next let's say 50 to 60 years. Like we are already at 90. Like many people who are born today will live till 90. 100 is doable. Like 150 is the hard part, and once we start to figure that out, of course once we reach 150 there will be more challenges, but it is solvable. Now the physics has provided us the answer. Biology is also like, okay, we can be done, but this sort of things you have to figure it out. How do you actually make human live longer? So once we start living in centuries, our perspective will change, because then let's say Venus project would be like, okay, I'll do it, my grandson will see it. Like that's something close enough. That is something close enough that you can actually say, you know what, I should invest in this because my family will live to see it. Not like my grand, my family will see it. So this will truly open humanity's eye to long-term projects. Then moon mining is absolute. Like there is no future of humanity unless we figure out moon mining. Now, reality of Mars, this is why I actually hate Elon Musk, is like when he showed his presentation, he literally showed this. Here's Mars, and Mars starts spinning. Of course, it has day and night cycle, so awesome. And it magically becomes like Earth. It's like it has now ocean, it has now atmosphere, and people are living there. I'm like, what? Let's say you give it ocean, let's say you give it atmosphere, it will not hold it for more than few hundred years. And I'm talking few hundred years, in like 300-400 years. So like, how do you magically expect it to hold atmosphere? It does not have enough gravity. And when he showed this diagram, I had one of my friend who is a very big gamer. He's like, what is this? This is literally looks like copy pasted from a game, like, you know, city builder game. It's like, that's not how easy it is. Like, you just go there and build glass domes. Radiation will kill you. Like, you can check my episode here where I figured out you can't use windows on Mars or moon. Yes, you have to use mirrors. Like, check that episode for full detail. So basically he's overselling it. That's why I hate this him. It's like he's selling the idea that we go to Mars and tomorrow all our issues are solved. We have Earth 2.0. No, it's not Earth 2.0. It does not have an atmosphere. It does not have radiation shielding. It does not have gravity. So we can't come back. So it's like, and there is no way to power things on Mars. Like, how the heck you gonna power it? Outside of flat out super gigantic solar systems, as in like solar power dish or giant nuclear reactors, there is no way to power anything on, you know, Mars. How the heck you gonna do that? So it's like he just shows this, and like even my friends like, dude, that's, I think, I do not know which game is, like Age of Empire or something like that. Like, you know, it literally like that's not how easy it is. Like, so once people actually go there, of course I'm talking about manned mission, once people actually go there and come back, then the excitement around Mars will come down. It's like, okay, we did that, it's a good training ground, awesome. I'm totally on board of it. But if somebody says Mars will become Earth 2.0, yeah, that's not happening. Physics is not on your side. So this was my presentation on why we need to terraform Venus, and I hope you liked it, learned from it. In that case, please leave a like. If you didn't, don't worry about it, you can dislike it, and I would urge you to leave a comment what you want to see in the next episode of Future Friday. And as always, please subscribe, share it amongst your friends, and press the bell icon if you're free. And as always, thanks for watching.